Okay, so what we have here is we have what we like to call two-step equations. And when we're working on two-step equations, we're going to be solving for some variable. Solving for a variable. And in this case, when we look at number 2 on that pre-assessment, it says something like this. It says 3x minus 7 equals 14. And the reason we call it two-step equations is we're going to have to perform two different functions to be able to solve for x. And when I talk about functions, that's a very loaded word in math. Functions are a very complex thing. But we have our 4 basic functions, right? Does anyone want to take a stab at the 4 basic functions we use in math? They're so simple you're probably not even thinking about them. Yeah? Awesome. Addition, subtraction, multiplication, and division, right? These are our 4 basic functions. Addition and subtraction are reciprocal, meaning that if you're plussing something and then minus something, it'll cancel out. And then multiplication and division are reciprocal, which means if you multiply by something and then divide by that same thing, they'll cancel out and you'll end up where you are. So every time we're talking about two-step equations, these are the steps we're talking about. We're going to add, subtract, multiply, or divide. And we're going to do that twice. So when I'm looking at an equation like number 2 there, 3x minus 7 equals 14, my goal is to figure out what x is. But before I can do that, I really need to look at my equation and know what is happening to x in the first place. So when I have 3x there, what's happening with that? What is that 3x telling me is going on? Yeah? Yeah, by whatever our number is, our mystery number, right? Yeah, this is multiplication. We kind of do it shorthand. We could write 3 times x, but you can see how that gets confusing if we have that multiplication sign. That suddenly it's like 3xx, and if your handwriting is bad like mine, suddenly you don't know what the heck you're doing. So we never do this. We don't have time for that. So instead we just write it 3x, and we know that this is multiplication. Multiplication. Beautiful. Okay, and then I have this here, which minus 7, which means I'm subtracting 7, right? I don't have to get too complicated on that. Subtraction, and all of that is going to equal 14. Now, you guys may remember a little something we call the order of operations, right? Order of operations. Sometimes we shorthand this as, please excuse my dear Aunt Sally, or some of you guys just say PEMDAS. Thumbs up, you've seen this before. Thumbs down, like, oh my gosh, you're blowing my mind with this mathematical knowledge, right? We've seen this before, right? This isn't old. And these each mean something, you know. This tells us the order in which we do things. So P means parentheses. E means exponent, so that means like if I have x squared, that's when I do this. M and D, while written MD, are the same thing because this is multiplication and division. They happen at the same time. And then A and S is addition and subtraction, right? Little bit of review. Whoops, it's going off the screen there. Little bit of review, but that's important for what we're going to be doing. So what I'm going to do when I look at my two-step equation here, when I look at my 3x minus 7 equals 14, and you guys see I keep writing it over and over again because each time we're looking at it, we're looking at a different element, and so rewriting it helps that. What I'm going to do is I'm going to work backwards through my order of operations. So the first thing I'm going to go backwards here. So I'm going to start at S and A. I'm going to see, is there any addition or subtraction going on here that I can get rid of? Yeah, absolutely. I have this minus 7. So to get rid of the minus 7, since it's subtraction, I have to do the reciprocal function. And the reciprocal would be addition. So what I'm going to do is I'm going to add 7 to get rid of that. Now, an equation is something special. Okay? An equation means that these things are the same. So, you know, what does everyone do? They always say a scale. Like we ever use scales, right? We have a scale like this, right? And if I'm going to add 7 here, well then the weight's going to shift up like that. So I have to add 7 to both sides. The equal sign is going to be like that scale telling me I have to add 7 to both sides. Next step, these cancel out. The -7, the +7 ends up being 0, leaving me with 3x on the left side. And now on the right side, I have 14 plus 7. 14 plus 7 is 21. All right. Thumbs up if you're with me so far. Thumbs down if you're like, Victor, can you slow down and so I can see that one more time? I'm not quite sure what's going on. Okay, cool. We're looking good. Any other questions, like off the cuff, that I can clarify? Don't be shy. Beautiful. Easy enough. Yeah?
Are we supposed to write down everything you write up there?
I would. I mean, you guys are creating the textbook with me, so, you know, write down the important stuff. And I'll leave this up here for a minute once I'm done with the lesson so you can kind of see everything. All right, so we got 3x equals 21. This is what we would call step 1. In the step 2 equation, I added 7. Now I'm going to go on. I got to do one more thing. I got to go to step 2 here. Okay, what are we going to do for step 2? Yes? Yeah, we're going to divide by 3 both sides. We have multiplication going on here. So we need to do, if we have multiplication, we need to do the opposite function. We need to divide, in this case, by 3. And you guys see how I'm dividing here? I just make it look like it's a fraction. It's the same thing. You know, our division sign looks like a fraction itself. Fractions and division have that relationship. They're kind of the same old thing. We divide by 3. 3 divided by 3 is 1. That's why we did it. X. 21 divided by 3. Anyone that plays a lot of blackjack knows that's going to be 7. And so we have x equals 7. Beautiful, beautiful. All right. So that's the basics of our two-step equation. You know, all that we're really looking for is we're looking to see, you know, what are the two things that we're doing here? In this case, it was multiplication and subtraction. We work backwards through the order of operations, and then we do those steps to isolate our x and solve. And sure enough, we can double check this to make sure that it's right. We can plug 7 into the original equation. So I have 3 times 7 minus 7 equals 14. And you see when I plug something in for a variable here, I write it in parentheses. 3 parentheses 7 is the same as 3 times 7. I feel like this is just a very clear way of saying, hey, there was an x here, now it's a 7. It's much clearer than trying to write the multiplication symbol. 3 times 7 is, well, 21 minus 7 equals 14. 21 minus 7 is 14. Does 14 equal 14? Yeah, it totally does. Boom, check. Totally did it right. Now, for your work, when you guys are doing this sort of problem, this is what I want to see right here. This whole bit right here. You don't even need the step 1, step 2 part. But as long as you're showing me plus 7, divide by 3, divide by 3, boom, I got it. And now I know we can add 7 in our heads fairly easily. I know we can divide by 3 in our heads fairly easily. I still want to see your work on this. I still just want to see there's 1 step, there's 2 step, done. Yeah?
Is the line through the problem number?
Yes. If I just did like an X, and then I would do a check if you did what I wanted you to, a plus if it was amazing. But if I didn't mark it at all, that means you did it right.
Okay, but I got a line for this one that I did exactly the same one.
Okay, well, let me see it later. Maybe I was on autopilot, or maybe there was something else I wanted to show you. Easy enough? Okay, let's look at the number 3 here. This one was a little bit more challenging. Okay, I'll leave this on the side here. When we're looking at the problem we did for number 3, we have what? Y over 4 plus 8 equals 12. All right. And again, let's just identify what's going on here. This y divided by 4 is telling us what? What's that saying? Yeah. Division. Right? We're not saying fraction. I mean, yeah, we are. It is a fraction, but we have to get used to looking at fractions as just division. right? You know, if I say 1/2, right, we're all comfortable with that. 1/2. You know, I ate half of a cake last night, and boy, do I feel terrible. No, like 1/2 is 1 divided by 2, sure. That's how we want to view it. 1 divided by 2, 0.5, etc. Well, y divided by 4, yeah, it's y fourths. We don't know what that is. But it's also just saying y divided by 4. So we'll just say division. And then plus 8, I hope we see, is addition. So I'm going to work backwards through my order of operations. What am I going to do first? Am I going to cancel out the division or am I going to cancel out the addition? Remember, we're going backwards. PEMDAS. And we're going to go backwards through it. So what am I going to do first? Yeah. Yeah, let's get rid of the addition. And to get rid of the addition, how do I do that? Yeah, you subtract. Beautiful. All right, so I got y divided by 4 plus 8 equals 12. I'm going to subtract 8, subtract 8. That gives me, this cancels out, becomes 0. Y divided by 4 equals 4. Awesome. So now I have the division. What do I do to get rid of division? I multiply. Right? So what am I going to multiply this by? Everyone hold up the number of fingers what I'm multiplying that by. All right. I want to see it from everybody. What do you guys think? All right, beautiful. I'm going to multiply by 4, multiply by 4. That'll cancel out. Y equals 4 times 4, which is 16. Okay, and that's going to be our answer. How many of you guys got this one right? Like, just thumbs up, you nailed this one, okay? How many of you guys, like, this is what tripped you up if you got it wrong? Like, just seeing that, you're like, Victor, what the heck, what do you want me to do with that, okay? Cool. I want us to get over that. I want us to kind of see that, yeah, it looks like it's a fraction, but really, it's just simply division. And we know how to multiply, we know how to divide. That's not that tough. So from there, we can just fix it. Easy enough? Cool. All right, so now we've talked about two-step equations. The other thing I want to focus on are inequalities. Inequalities. I gave you this very long, complicated, challenging word problem for number 4. And honestly, this is one of those like challenging problems that I just kind of toss out there, not expecting a whole lot of people to get it. So those of you that did get it, you guys should feel really good about yourselves. You guys nailed it. You worked hard. You must have studied a lot of math in your youth, and you've come super prepared. But I didn't really expect everyone to be able to get number 4 because it is a bit of a challenge. But one of the things I do want to talk about is I want to talk about inequalities because we know that the equal sign means that something is something else, right? It pretty much means is. You know, x equals 4 means x is 4, right? We use those terms interchangeably. Okay. So when I start using inequality signs, I'm looking at something like this. Okay, you guys remember this bad boy? What does this one say? Maya?
4 is greater than x.
4 is greater than x? Yeah, but I like to read left to right, so I would say x is less than 4. But you're absolutely right, where it's actually the exact same thing if I were to say 4 is greater than x, right? These are equivalent. These are saying the exact same thing. Okay. How many of you guys learned it like as an alligator? Like the alligator eats, yeah, right? The alligator eats the bigger number. And then I don't understand why the alligator, when we do the less than or equal to, I don't know what this stands for the alligator. Maybe he's a little bit more flexible. I don't get it. But like if I were to say x is less than or equal to 3, you know, less than or equal to, okay? If I were to say x is less than or equal to 3, what I'm saying is x isn't one number. So x is not one number. It's actually, x is infinite numbers. And this is a sign that means infinity, right? That means there is it's uncountably large how many numbers x can be, right? So if I were to say like x is less than or equal to 3, what I'm saying is like, x could be 0, it could be 1, it could be 2, it could even be 3. It can't be 4, 5, or anything like that, but it could also be, -1, -2, and I can keep doing that forever. And also, x could be anything in between. X could be 0.5. It could be 0.55. It could be 0.555. You can go on forever and ever and ever. There's an infinite number of ways that we can of ways that solve for x. So one of the ways that we want to visualize this, because this is a more complicated way of thinking about the world, is we start to have to graph it, right? We'll have a number line like this. I'll do like 0, 1, 2, 3, 4. You guys remember this bad boy? Oh, is it off the page? There we go. Thanks, man. Just like that. And then suddenly, I'm going to look at 3 here. 3 is the hot point. And so 3 is the hot point, and I'm saying x is less than 3. So that means I'm going to shade this line like this, all the places where x is less than 3. And then I'm going to put an arrowhead to show that it goes on forever. You guys see how I just kind of shaded on the top of this number line here to kind of show that it goes on forever? And then, since 3 is included in this, I'm going to color in this dot as well. That shows that 3 is part of the solution. So anywhere that I've shaded, and in theory this goes on infinitely all the way to the end of the universe, and then some, that would be my way of showing that x is less than or equal to 3. Thumbs up, this is kind of review. Thumbs sideways, somewhere in between. Thumbs down, this is the first time you've seen it. Okay, cool. This is awesome. All right, so we know what? We know a lot of things. So let's imagine a scenario where it's a two-step equation that involves an inequality. Let's go all the way back up to this one here. Okay, let's imagine that instead y divided by 4 plus 8. How about instead of equals, this was greater than 12. Okay. Instead of all I did was I changed the equal sign to a greater than sign. So what really changes here? I mean, not a whole lot. We still do the problem pretty much the exact same way. I look at my 8. I'm gonna subtract my 8. Subtract my 8. So I have y over 4 is greater than 4. I'm going to look here. I'm going to see that it's divided by 4. So I'm going to multiply by 4. Multiply by 4. So I have y is greater than 16. Okay? And that would be the answer. I might do something like this where I have 15, 16, 17. I'll make my dot. Where is y greater? It's greater over here. It doesn't have the or equal to sign, so I'm going to leave this as an open dot. Right? If it doesn't have the or equals to, it becomes an open dot. And that would be my answer. Questions on any of this so far? Thumbs up, this is crystal clear. Thumbs sideways, a little murky. Thumbs down, like we're swimming in a bog right now. Okay? Cool. Crystal clear to murky, that's fine. I'm okay with that. All right, one final exception to all of this, because there's always an exception. We always got to treat the special rules here. So let's imagine instead I had negative x minus 2 is less than or equal to, we'll say 4. Okay? And I asked you to solve and graph this. I said, hey, solve and graph. Okay? All right, we're going to go through the same steps we normally do for a two-step equation. I'm going to see that I have a minus 2, so I'm going to add 2. I'm going to add 2. This will cancel out to 0. I have negative x is less than or equal to 6. I then see that there is a negative attached to this x. And what that really means, of course, is that we imagine that this is actually negative 1 times x, right? But just to save ourselves time, we don't write the -1, we just write it as negative. So these are equivalent. So I have this -1 being multiplied into x. I want to get rid of that. How am I going to do that? Same way I get rid of anything that I multiply, I'm going to divide by -1. -1. Okay, so negatives divided by a negative, that becomes positive x. 6 divided by -1 becomes -6. And then here's where something happens. Because I multiplied or divided by a negative number, my sign is going to flip. So that's going to become greater than or equal to. So anytime you multiply or divide by a negative, you're going to flip your sign. And this makes sense, right? You know, if I said 5 is greater than 2, we all know 5 is greater than 2. I mean, do you want me to give you $5 or $2? Well, you want me to give you $5 because it's more money. Okay? Well, if I were to make these negative instead, if I were to then divide by -1 by both sides, I then have -5 on the left and -2 on the right. Well, my -5 is not greater than -2. You know, it's actually less than. So our signs flip. So there's your proof right here. This is our little proof. Proof. Deal with it. That's how it is. Flip the sign, do your thing. Awesome. Any clarifying questions? You guys ready for this? Thumbs up if you're ready to dive in and get some work done. Okay, cool. How many of you guys want me to leave this up for a little bit longer so you guys can copy it all down? Beautiful. I will do that. It's A-okay with me.